Hello everyone, my name is Amit Kumar Mohanty. I am educator at Mentor for You. So in today's class, we will understand what is integration by parts and we will apply the formula of what is the integration by parts and apply a particular formula on a particular question and see how the formula and how works and how to solve a particular question. Now, before proceeding forward with integration by parts, let's first understand on which type of situation will the integration by parts apply. So in such type of questions where we have to multiply two functions and I have to integrate them, in this type of situation we need to use integration by parts. Or in such type of function where the function is non-terminating, let's say x square, after differentiation it is becoming 2x, then after differentiation it is becoming 2, after differentiation it is becoming 0, it is getting terminated here. But let's say another function is sin x, after differentiation of sin x it is how much, cos x, then differentiation of cos x is minus sin x, then differentiation of minus sin x is how much? Minus cos x. And differentiation of minus cos x will be plus sin x. So you can see what is happening. The original value was getting repeated after getting the derivative multiple times. Yes. So that is in this type of situation where you are multiplying two functions or you have to find an integration of two functions where one of them can be such type of a non-terminating. In this type of situation, you can also use integration by parts. Okay. So let's I'm writing the value. So particular formula, then you can able to understand in a better way. So integration of u v equals to, what is the formula? U into integration of v minus differentiation of u. Let's say if it is in terms of x, if you have to differentiate, so du by dx multiplied with integration of v, then whole integration. So first what you have to do, first you have to keep u as constant, multiplied with v minus differentiate u, then multiply with the integration of v. After getting the new product, which is differentiation multiplied by the integration, now integrate the whole value. Clear? That is the formula of integration by parts. Let's say if there is some limits are given, let's say I'm giving some limits 0 to infinite. In this type of situation, the limits will be applied only here and here. The 0 to infinite and 0 to infinite. The limits will be not applied here because it is telling that you have to just integrate and then multiply the value. Then finally integrating this whole, apply the limits. The limits are not applied in the particular integration which is inside the operation. Clear? Now, so yeah, this is a particular formula and let's solve a particular question so that we can understand how is this formula applied. Now, this is question B, I equals to sine kx multiplied by e to the power minus x integration 0 to infinite. Yes, this is our question. So we need to solve it. So let's go to the next page and start solving this particular question. Okay, let's go. Now, I equals to, what is the value of I? Yes, integration of 0 to infinite sine kx into e to the power minus x. Correct? Let's now apply the by part formula. So first into integration of second. So if I'm applying it, how much it will be? So I equals to sine first into integration of second. Integration of e to the power minus x is minus e to the power x minus x. It will be e to the minus e to the power minus x. Clear? Now, in this part, what we have to do? Since we have limits, we have to apply limits on this part. So first into integration of second minus differentiation of first. So differentiation of first is cos kx sin x. Kx differentiation is how much? Cos kx into differentiation of kx is k. So the differentiation will be cos kx into k. Clear? Then multiplied with integration of e to the power minus x is how much? Minus e to the power minus x. So it will be how much? Into minus e to the power minus x. Clear? Okay. And we have to integrate this whole function 0 to infinite. Yeah. Now, let's solve this particular part. So how do you apply the limits? First, you have the upper limit, subtract by the value you will put in the lower limits. That means we have to replace x with value as infinite minus replace x as 0 and then get the final answer. So if I'm putting x as infinite, what is happening? This term is minus 1 by e to the power x. Correct? I'm writing e to the power minus x as 1 by e to the power x. Okay. So if x is infinite, what can I see? 1 by e to the power infinite it will be. Yes, 1 by e to the power infinite. 1 by e to the power infinite means 1 by infinite means the output will be 0, because as the denominator increases, the value decreases. So if the denominator is infinite, indicating what? Think, indicating that the value will be 0. So 1 by infinite is how much? 0. So this particular term is 0 multiplied with how much? Sine k into infinite. So since we know that sine function maximum value is how much? 1, and minimum value is 1. So whatever may be the value, it will be range between -1 to 1. So it is a finite value multiplied with 0. That means the output will be 0. Yes, so this is the value that I got for infinite. Minus, I have to apply the value of 0. So if I'm putting the x as 0, what is I'm getting? Sine kx, k into 0 equals to sine 0. Sine 0 means 0 only. So 0 into 1 by e to the power x. If x is 0 in this situation, it will be 1 by e to the power 0, which is 1. So it's basically, what can I say? 0 into 1 for x equals to 0, because sine 0 is 0. So what I can get the value as for 0 also 0. So for infinite also 0. For 0 also it is 0. So 0 minus 0 will be 0. Clear? Now, let's come to the first part or the remaining part. With this part clear, what we have? Minus of, what are the things present here? Let's take it out. So minus k, because we have to integrate this part, and this is our original question. I equals to, we have to find out. Till now we have reached this particular situation, and we have to integrate this many part. But the thing is, this k is the constant value. So in integration, we can take the constant out, and we have a negative sign here. So I'm taking minus k in the outside. Integration of 0 to infinite cos kx into e to the power minus x. Clear? So this minus and minus, let's make it as plus. So I equals to k into integration of 0 to infinite cos kx into e to the power minus x. With that same previous logic as I led, this is also a trigonometric, this is x1 xl. So this one will be u and this one will be v. So u, what is the rules of bypass? First into integration of second is e to the power minus x, integration is minus e to the power x into minus e to the power minus x. Clear? So first into integration of second and apply the limits here, minus differentiation of first. Differentiation of cos kx is how much? Minus sine kx. Correct? So minus of minus sine kx, and differentiation of kx is k. So this is the differentiation of cos kx. So differentiation of first. So first into integration of second minus differentiation of first into integration of second. Integration of e to the power minus x is minus e to the power x into minus e to the power minus x. Yes. Is this clear? And we have to apply the what? Limits on this particular part. 0 to infinite. Clear? You can see what is happening. The question is getting repeated here. So what I am doing here next, I equals to, let's keep the value as it is, or let's apply the formula and get the output. Okay. So for x equals, let's put the value as x as infinite. In that same situation, what happened? I have e to the power minus x. That means 1 by e to the power x. Yes, in this type of situation, 1 by e to the power x output will be, if x is infinite, it will be 0. 0 multiplied with cos kx. Cos kx, if x is infinite, will give me a what? Same value as sine, a definite value within 1 or minus 1. So a finite value multiplied with 0. The output will be 0. So for infinite, the output is how much? 0. Correct? Now, with that same logic, let's apply the value of how much? Think minus of, we have to apply x as 0. So if I'm putting x as 0, what is happening? This cos kx, x as cos 0 will be 1, because k into 0 is 0. So cos 0 will be 1. Yes, 1 into minus 1 by e to the power 0. I'm writing 1 minus e to the power minus x as 1 into 1 by minus e to the power 0. Clear? So e to the power 0 means 1. So 1 multiplied by minus 1. So the output will be minus 1. So 0 minus of minus 1. Clear? Yes. Is it clear? Now, if I will solve this particular value, what I will get? Think minus of -1 multiplied by k. The output is k. Clear? Minus of -1 is +1. So k into 1 is k. Now, with this particular part. So before multiplying the k, I'm leaving it as it is because we have found this particular value, which is 1. So it is 1 minus, yes. Now, in this situation also, what is happening? Think, after differentiation of this particular value, what happened? We solved for this differentiation. Yes. First into integration of second minus differentiation of first minus differentiation of part is minus sin kx into integration of second is also minus second whole integration. This minus and this minus will get cancelled and it will become plus, correct? So 1 minus, what is happening? You can see 1 minus integration of 0 to infinite. I'm taking the k outside, sin kx into e to the power minus x. Yes. Also, you can see integration of 0 to infinite sin kx into e to the power minus x is also my I also. You can see I have written in the first question. I equals to 0 to infinite sin kx into e to the power minus x. Clear? Now, if I'm applying that same logic here, what I can see? Let's solve it a little bit. I'm going to the next page. So I equals to what? K into what values? 1 minus, this value will be how much? I. So 1 minus ki. Yes. So 1 minus ki. Clear? Now, let's open the brackets. So I equals to k minus k square I. Clear? Let's take this I, k square I to that side. So I plus k square I equals to k. If I take I as common, it is 1 plus k square equals to k. Or I can say I equals to k by 1 plus k square. Clear? And this is our answer, because what was our question? Our question initially was to find what is the value of I? Value of I. Clear? Yes. And finally, what did we got? We got the value of I as k by 1 plus k square. Correct? Or I can say, if the original question, what was that? 0 to infinite sin kx into e to the power minus x. Yes. Let's say if I change the form little bit, if I take it as 0 to infinite sin bx into e to the power minus ax, the output will be how much? The output will be I equals to k in this situation is how much? B. So b by, and this is 1 square. So this is b by a square plus b square. Clear? Let me write it in a perfect way. Yeah. So I equals to b by a square plus b square, which is the value also that we are getting here. So in this particular question, what is happening? We are just replacing the value b with k, and how the particular question follows theorem works. I hope you are able to understand. So yeah, that's all from my side. I hope you're able to understand this particular question. After I have uploaded the video, you can let me know in the comments if you want the particular PDF as well, where I have written all the steps and step-by-step explanations. I can give you the PDF. Just let me know in the comment section, or else just drop me a mail. So yeah, thank you. Take care and remain safe.